Hi, I'm Jacob Rapstein, and I'm here to talk to you about big data and how it's used in the NBA. So we're going to start off with APBR metrics, and what that is that's the Association for Professional Basketball Research Metrics. All that means is their end to statistical analysis of basketball. APBR metrics are closely related to sabermetrics, which we talked about earlier this semester if you remember talking about Moneyball and using statistics in baseball. Well, like sabermetrics, APBR metrics, which we're just going to call advanced metrics from here on out, uses massive amounts of data to solve a sports problem. So why is this important? Well, advanced metrics are more important now than ever because teams are always open to better ways of evaluating players. The benefit of using advanced metrics is seeing the game in a new way, whether it be seeing which group of five guys play the best together or seeing who's the best defender on LeBron in the paint in the fourth. Now, advanced metrics can answer these questions and much more. So before the wave of advanced metrics, most teams used box scores and stat lines to portray how well a certain player or team performed. So we're going to go over this traditional box score, and then we'll compare it to a newer one. So right here, starting from left to right, we got minutes right here. That's just minutes played. FG is field goals made. FGA is field goals attempted. 3P is three-pointers made. 3PA is three-pointers attempted. And then we got free throws attempted. OR stands for offensive rebounds. DR is defensive rebounds. TOT is total rebounds. A is assists. PF is player fouls. ST is steals. TO is turnovers. BS is block shots. And of course, PTS is points. Now, this first box score is pretty easy to find out what happened over the course of the whole game. But imagine you're a general manager and owner that wants to gain that competitive edge that every sports franchise is seeking nowadays. You want to compare these players on a level playing field. You can't compare Alex Shved right here with Corey Brewer because Alex Shved got 5 minutes compared to Corey Brewer's 24 minutes. That's where advanced metrics come in. So advanced metrics, here's a newer stat line. As I look at this box score, I see a lot of columns that I used to wonder, what does TS percentage mean? What does USG percentage mean? How do they come up with these numbers? Why are they important? And well, what is this all about? And I'm going to talk to you about that today. And we're going to start off with TS percentage, which is actually true shooting percentage. And that is found by taking 100 times half the total points scored and divide all that by your field goals attempted plus the product of 0.44 times free throws attempted. And the reason we use that 0.44 number is, on average, the equivalent number of shots taken by a player is 0.44 times the number of free throws attempted. And you're going to see that 0.44 later on. It's going to be a recurring number because it's used in many advanced metrics. So true shooting percentage is one of the most popular metrics used today. And unlike field goal percentage, true shooting percentage gives weight to the fact that three-pointers count more than a two. It also takes into account for how many fouls a player draws. The idea behind this is that it takes into all the points a player gets via field goal shooting and foul shooting, which those are not normally accounted for by your normal field goal percentage. So many of the best players in the league heavily rely on foul shooting to get their points. Harden, Durant, always shooting free throws. Well, because free throws are so much easier to make than field goals, these players tend to get points easier, or you might say more efficiently. Therefore, users of advanced stats tend to like true shooting percentage more than field goal percentage when talking about a player's shooting efficiency. And that's the key word here, is efficiency. Now let's move on to effective field goal percentage. And effective field goal percentage is found by taking the number of field goals a player makes, add that to half the number of three-point field goals he made, and divide that sum by the total number of field goals attempted. Now, if a player never takes any three-point shots, then his effective field goal percentage will be equal to his normal field goal percentage. So really it just weighs three-point shots different. And 3-point shots are weighed 1.5 times the normal shot on here, if you look at that formula. And this does make it possible for a player to have a percentage greater than 100%, but the idea behind this is that it takes into account and rewards players for making shots that are worth more. I like this because it shows how you shot from the field, not how many free throws you made, because free throws are technically not shots from the field. I want to see how many shots you made with a guy guarding you in the game while it's going on. Now let's move on. Pace and volume adjusted stats, which we're going to call tempo free. So tempo free stats are used to accurately compare players who receive different minutes. Say I'm a coach and I have player A and he got a double-double. He had 10 points, 10 rebounds in 36 minutes of action. And then I had a guy come off the bench who's player B and he got 8 points and 5 rebounds in only 12 minutes. Well, player A received 3 times as many minutes as player B, but what stats would have player B produced had he played 36 minutes? This is why we use percentages. They give us an accurate description of what a player does on a per minute basis. One flaw with tempo-free stats is pace. Teams that play at a quicker pace are more likely to have inflated per game or per minute stats. So the Heat, Wizards, teams that really run up and down the court are going to have more inflated stats. Now that doesn't mean they're going to look better than they are. They could look worse. It's just it's going to be more extreme than what it normally would be. So their tempo-free stats are going to be inflated one way or another. Here are some examples of tempo-free stats. So right here we have offensive, defensive, and total rebounding percentages. And these are all calculated in a similar manner. The formulas compare a player's actual rebounds versus the amount of rebounds he could have gotten while he was on the court. This gives us a percentage of the chances a player has of getting a rebound given the situation. I personally find offensive rebounding percentages to be the most important because offensive rebounds yield extra possessions, which yields more points. Let's continue on to assist and steal percentages. And assist percentages are pretty straightforward. They tell us what percent of shots a player assisted his teammates on. So this is preferred to a normal assist rate because it adjusts for pace and minutes played, just like all these tempo-free stats. And on to steal percentage. Now this one I'm not too wild about, but I'm going to tell you about it anyways. It calculates the percentage of an opponent's possessions that end with the player stealing the ball. So in other words, if so-and-so is guarding LeBron, what are the chances he's stealing the ball and taking it on that specific play? Now the reason I don't like this is there's no way to account for missed steals or putting yourself out of position, which really puts your team at a disadvantage. And for that reason, I find steal percentage to be almost useless. Because then you have players in the top 20 of steal percentage like Monte Ellis, where they're just swiping to get steals all the time, but they're still getting burned on the basket. They're still getting burned to the basket when they miss that steal, but it doesn't account for that. It only accounts for the steals they do get. So, I don't know. There could be a new way of doing that. But for that reason, I consider this one of my more skeptical metrics compared to others. Block and turnover percentages. Block percentages are the percentage of opponent's shots that a player blocks. Like all tempo-free stats, the block percentage gives us an easy-to-compare percentage to compare players no matter what kind of minutes they receive. Now, the problem with block percentage, which it's not necessarily a problem, it's just the way the formula is set up, but it weighs 3-point blocks at a higher weight than 2-pointers, which is fine because 3-pointers are more valuable than 2-pointers, but a block 3 would add 1 to the block shots without adding a shot attempt. This skews the data for people who block more threes. Turnover percentage is kind of like assist percentage. It's pretty straightforward. It's estimate of turnovers per 100 plays. So you're in 100 plays, how many times are you turning the ball over? And that's it. Now we move on to usage percentage. Now, usage percentage is an estimate of the percentage of team plays used by a player while he was on the floor. In other words, it's kind of indicative of how much your offense runs through a certain player. For example, Carmelo, Russell Westbrook, James Harden, Kobe Bryant were all unsurprisingly in the top 5 for usage rates last year. That's because they dominate the ball, they're all high volume scorers, and they shoot way more than average. Let's move on to PER. Now, created by John Hollinger, PER is an all-in-one basketball rating. Notice I say all-in-one in quotes. It accounts for a player's permanent performance while adjusting for pace. And it uses a very complex formula, one that I couldn't even fit on this slideshow. And what that formula takes into account is positive accomplishments like free throws, three-pointers, field goals, assists, rebounds, blocks, steals. And then it takes in the negative ones, such as missed shots, turnovers, fouls. And then it gives you a score through a point system, and then it takes that score and adjusts it to a permanent basis so that substitutes can be compared with starters in playing time debates. It also adjusts for the team's pace, but that's at the end of the season. And why it says right here that the league average PER is always 15, that is used as an index, and the formula actually changes each year to fit that index, if that makes any sense. But that index, how we use that, say a person had a PER of 16, we would say he's above average. If he had a PER of 14, he's below average. So that's how we use that. But Hollinger, there's a few flaws. And although useful, PR is not the perfect stat. It's just a tool. And I like to look at it as an offensive efficiency rating because I truly don't believe it takes into account. I don't know if there's anything that takes into account defensive efficiency rating yet. And my reasoning for that is Bruce Bowen and Ben Wallace, who are two of the greatest defenders of the past decade, consistently produced single-digit PERs, which should not be happening. But so for that reason, and also Hollinger has set his weights on his scoring so that inefficient scores still look pretty good. I argue that inefficient scoring reduces a team's ability to win games, which results in these players not being nearly as effective as their PER leads people to believe. Those two reasons are enough for me not to listen to PER numbers. I find the more specific stats to be of more use. So, kind of wanted to talk a little bit about John Hollinger because I find him to be a winner, and I think he's combining my two favorite things, math and sports. And he's combined them into an impressive career that has been successful to say the least. Well, Hollinger has always been a statistician, and he has worked for Sports Illustrated, ESPN, and now the Grizzlies. But I am more focused on his work for the Grizzlies. He took over last year in December as VP of Basketball Operations. And by the end of January, he had convinced the management to trade the Grizzlies' best player, All-Star Rudy Gay. Now, many analysts and fans thought that Hollinger and the Grizzlies front office were insane for trading away their All-Star. However, advanced metrics predicted the Grizz to be a more efficient offensive team with Gay gone. The idea behind these metrics was a slasher like Gay can't play to his maximum potential with two big guys clogging up the lane, those two posts, Zach Randolph and Marc Gasol. And they weren't about to trade either post because posts are a valuable commodity, so they decided to trade Rudy Gay. Very effective. Well, comparing the Grizzlies' splits before and after the trade is telling. Prior to the trade, the Grizzlies had an offensive rating of 100 with an effective field goal percentage of 46 and a true shooting percentage of 50. Since the trade, they had an offensive rating of 103, an effective field goal percentage of 48, and a true shooting percentage of 52. That's 3 more points per 100 possessions, along with increased shooting efficiency, not to mention the $15 million cleared in cap room space. I'd say it was a good trade just by the numbers. But how did they do in the real season? How did they actually perform? They beat the OKC Thunder in the Western semifinals and advanced to the Western Conference Finals for the first time ever in franchise history. And I would say the Memphis front office is a prime example of advanced metrics and how they can be beneficial. The Grizzlies recently made another headline-grabbing move by not re-signing their head coach after he had led the team the furthest they have ever been. Rumor is the coach wasn't re-signed because of his dislike for advanced metrics. Which, I don't know why you wouldn't like advanced metrics. So, where is advanced metrics heading? What's going to happen in the future? Where's it headed? And one of the newest measures of advanced statistics is player tracking. We're going to show you an example right here. What this is player tracking uses 6 rafter cameras to track the movements of every player on the court. These cameras take 25 snapshots a second, giving us a very accurate model of what the player did the whole game. Excuse me. This opens up a plethora of innovative statistics that we can now use. Some examples are how much the person ran the whole game, how fast he ran, player spacing, how far he traveled the whole game, how many touches he had, how many passes he threw. It's really endless possibilities. So player tracking. It can calculate all the tempo-free stats measured earlier, and I might note I didn't note every tempo-free stat that there is. And it also gives us more in-depth stats like an opponent's field goal percentage at the rim or number of field goals allowed at the rim per game, which in today's high-scoring NBA is a huge cause of concern. Every man wants a big man who can protect the rim and anchor down the paint. And now player tracking allows us to see who is the most efficient at protecting the rim. Now granted, this statistic is more valuable for posts and guards, but as stated earlier, I like using the more specific tools or the more specific stats because they kind of give you a greater idea than those broad PER numbers or something, you know. Well, because this is still in its first few months of use for the public, we don't know the full benefits of player tracking, but it will definitely be a major tool used in the future. And I say public use because some data companies have been working to implement this for quite some time, but this is the first tracking system that is widely available to the public. This makes the NBA the very first national sport to quantify and analyze every moment of a game action. I'm extremely interested in the use of big data being used in my favorite sports, and I look forward to seeing where the future takes us. If you are interested in player tracking or advanced metrics or even statistics, I strongly suggest you check out stats.nba.com. Thanks for your time, and it's been a pleasure putting together this presentation.